this lab, you will determine the freezing point depression of a solute when it's added to a solvent. Now take a look at this example. Here I just have plain water. That is your solvent. And here I also have plain water, but I'm going to add a solute. So as a solute, I'll just add this Kool-Aid packet or vitamin C packet. So when I add the solute to this solvent, there are two things that happen. And those two properties are known as colligative properties. So I'm just going to dump it in here. You can zoom in on that. And I'll stir it. And you automatically notice that when I added the vitamin C powder to my water, the color has changed as opposed to water by itself, solvent by itself. So relative to pure solvent alone, this solution, now remember what a solution is, it's a solvent plus solute. I've added this solute. This solution now has a freezing point that has depressed relative to water, pure solvent alone. And its boiling point has elevated relative to pure water, pure solvent alone. So when you add any solute to a solvent, we have a freezing point depression and you have a boiling point elevation. So in this lab, you're going to use the solvent of cyclohexane, not water, but you'll use the solvent of cyclohexane and determine its freezing point depression as a result of adding an unknown solute to it. To start this experiment, you're going to need to take a test tube as well as a cork or a stopper that fits in as a lid to the test tube. Now you'll see in the lab that there are different sizes of test tubes as well as different sizes of these corks. So make sure you find one that fits and is applicable towards your needs. So this is a medium-sized test tube. This is a number 2 size cork. Usually corks are, their size and shape are given a number. So this fits very fine with this test tube. You're going to have to do some experimenting on your own when you encounter all these different size test tubes and all these different size rubber stoppers in the lab. Another thing that's possible is if you're unsuccessful in finding a test tube of appropriate size with a rubber stopper of its appropriate size, you can take one of these long slender test tubes and just put in the temperature probe in like this. That's also possible. So we're going to weigh a blank of our test tube alone with the rubber stopper on. And my blank, my scale is here. It's tared to 0. And I'll just put it here as my blank and weigh out the weight. The weight is 12.500 grams. So make sure you note that in your lab notebook as well as your data table. And now the next step is to actually put in roughly 6 grams of cyclohexane. Now you don't really have to weigh out exactly 6 grams. So approximate 6 grams or approximately 6 grams would suffice. As long as you note down the exact number that you weighed out in your lab notebook and in your data table, you should be fine. So I'm going to take this 1 ml pipette and roughly fill it in 5 times. Okay, so here's 1 ml, or maybe even 6 times, but okay, so that's 2 mils. So 1 ml, 2 mils, about 3 mils. And I get 16.870 grams of test tube plus the rubber stopper along with my cyclohexane. So I could weigh by difference in order to determine the mass of the cyclohexane. If it's around 6 grams, you're good. If it's around 5.5, 5.7, it's fine. If you're a little over 6 grams, that's also perfectly all right. We're just looking at an approximation. I weighed by difference and I got about 6.3 grams of cyclohexane. So I'm going to put my temperature probe in. let's clamp it onto this. I got my cyclohexane attached to my temperature probe. There's that rubber stopper there, and my temperature probe is connected to my GoLink, which is in the back of the monitor, so you may not see that. So we go to chemistry labs. Chemistry labs and temperature versus time. Okay, we're going to collect this for 10 minutes. All right. So let us slowly lower this into our ice bath, which contains ice and water, 100 mils of tap water with roughly 300 or so mils of ice. And we're going to immerse that whole thing in there. And make sure it goes all the way deep inside. Do a little stirring. And let's hit collect. And we are collecting data. I'm going to change the scale on my y-axis because you notice the temperature is starting out at around 10 degrees. This is my raw data, the actual data acquisition. So let's just change the y-axis. So do you remember how to do that? Just click. You see how that cursor has changed? The cursor is a white arrow. And now I move it up to 100. And I click on it, right click, left click, excuse me. And I'll change this from 0, not to 100, maybe 0 to 20. So I'll take 20 and hit enter. So it just scales up my graph. So we have 10 minutes of data acquisition. Every now and then, just stir it up with your temperature probe. It won't hurt if you add a little bit more ice. Certainly shouldn't matter. A little bit of chunks of ice. And let's keep on stirring this. Now that you've found the freezing point of pure cyclohexane and performed that run, the next step in the experiment is to take an unknown and use that as your solute and add it to your solvent of cyclohexane. So in order to do this, you're going to weigh out about 2 grams of this unknown. It's going to have a kind of a crystalline texture, and we'll weigh out about 2 grams of this. Okay, I got 2.175 grams, which is okay. Let's put this into a mortar and pestle. This is what a mortar and pestle is. It's just going to grind this up into a nice fine powder. So I crushed this up into sort of a powder, fine powder. It used to be prior to this crystalline. And I'm going to weigh out 0.06 grams of this. You'll weigh out 0.060 grams, roughly 0.06 grams. You don't have to be exact. And then pour it or put it into your cyclohexane that you ran before. Now make sure that cyclohexane, that once you've taken it out of the ice bath, you put it in some tap water to let it thaw. So just pour that cyclohexane into some tap water to let it thaw. Let it return to its liquid phase, and then weigh out 0.060 grams, roughly that amount, and then put it into that cyclohexane bottle. Now, that cyclohexane test tube, which you ran the pure solvent, now that cyclohexane test tube has roughly 0.06 grams of the solute. All right, I started the experiment, and this is, the blue is the cyclohexane with my unknown solute. I clicked on the green collect button and I clicked store latest run. All right, so that's what you want to do. Hit collect, store latest run, and now it's ready to, and it is, as we speak, collecting data. Now, as we see this real-time data acquisition, this is my pure cyclohexane. My blue is cyclohexane with that unknown solute. Remember, freezing point depression, so we should expect this curve to dip below the pure cyclohexane solvent, and that is what we are actually seeing happening here. All right, so we're going to let this run for another 10 minutes, and then I'll come back and we'll do the final leg of this experiment. All right, this is my cyclohexane with some solute that I added, about 0.06 grams, and I let it get out of the ice bath, and it's starting to thaw. To accelerate the thawing process, I'm just going to put it in a little water bath here. So that should thaw just fine. I have already added 0.06 grams of my unknown. The next step in this procedure is to add an additional 0.03 grams of unknown. So my first run, as a reminder, was just pure cyclohexane. My second run was pure cyclohexane with 0.06 grams of my unknown. And now this run is going to be an additional 0.03 grams added. And so what do I have? I have a total in my third run of 0.09 grams. All right, so my third run now is going to be about an additional 0.03 grams. I weighed out 0.045 grams, so we will put that in here. This already has 0.06 grams from my second run, remember that. And let's just fold it in here and put it in. All right, let's do our third and final run. All right, I'm ready for my third run. Let's go to the computer screen, hit collect, store latest run. My red one is pure cyclohexane. My blue one is cyclohexane with roughly 0.06 grams of the unknown. And my third one is an additional 0.04 grams added on top of the 0.06 grams. So about 0.09, 0.01 grams total now in my test tube. And we're going to let this run for 10 minutes. All right, we've got our three portions of the graphs. And now it's time to do our data analysis. We have a little bit of a bump that occurred in the apparatus while it was acquiring data. So that resulted in a rise in about 0.1 to 0.5 degrees in temperature because the bump occurred. So you want to be careful. You want to let the data acquire and not have any accidental shoves or pushes in the water bath. However, other than that, the data looks fine. We can annotate the data. So by annotate, that means labeling the curves. So under the first graph that I will label is the one that's pure cyclohexane. So in order to do that, I will go to Insert, Text Annotation. I can type in my text, pure cyclohexane. All right. Click on the white. And when my cursor turns into this glove, I can drag it. Also the line, when my cursor turns into this glove, I can drag it. All right. We can do the same for the other two. So the red one was pure cyclohexane. The blue one was cyclohexane with our unknown. So let me go to Insert Text Annotation again. I'll do unknown plus pure cyclohexane, or it's actually 0.06 grams of unknown plus pure cyclohexane. Make sure my cursor has turned to a glove. Drag it to my blue. Make sure my cursor has turned into a glove and drag it to the blue. My green line is the 0.03 additional added to the 0.06, so that's a total of 0.09. I actually added 0.04 grams, so it's about 0.1 grams plus pure cyclohexane. So let's annotate that under Insert Text Annotation. I'm just going to put the approximate sign here, approximately 0.010 grams. Make sure you note the real values that you weighed out in your lab notebook and in your data table. 0.01 grams unknown plus pure cyclohexane, that's total. So make sure your cursor turns into a glove, drag it. Make sure your cursor turns into a glove and drag it here. So everything is labeled. So to do your freezing point depression, what you can do is take that cursor that has that plus sign, and when it has that plus sign, you want to go in gray. You see the gray? You want to highlight the area where you find cooling. Where does the cooling occur the most, or where does the steepest descent occur the most? And so that actually occurs, in my eye, roughly around here, okay? So in the red, the blue, and the green, the cooling occurs the fastest, or that is where you have the steepest descent in your temperature decrease. So I highlighted that in gray. I'm going to go to Stat. And which run do I want to do? Run 1 was my pure cyclohexane, run 2 was my unknown, and my latest run was my unknown with the additional amount, the added amount. So I'll just do my run 1 pure cyclohexane. And when I do a stat on that gray area, I had a mean value of 6.154 degrees. That would represent, that would signify or symbolize my freezing point depression. I can click on stat one more time and look at run number 2. And when I do that, run number 2, as signified by the blue line, has a mean of 5.824 degrees. That would be my freezing point depression with 0.06 grams of unknown. I could click on stat a third and final time and do my latest run. Move that box to where it should be so that it would be easier to me to find it. And the mean of that green line is 4.670 degrees C. That would represent my freezing point with the total of 0.09, 0.1 grams of unknown added to pure cyclohexane. So you will know and utilize that equation with the freezing point depression constant to get the molality of the unknown, and ultimately from there you should get the molecular weight and the empirical formula and molecular formula of that unknown solute.